we're going to continue our discussion. So we are now on uh, Module 2, Lesson 1, all about thermal physics. So here we are going to talk about heat. We're going to talk about heat transfer, then thermal expansion, latent heat, specific heat, the Mayer's equation, and also some sample problems related to each topic. So let's start with the principle of heat. So when we say heat class, it is not actually a property of a material, because heat will just transfer from uh, one form to the other. So the basic example of the transformation of heat, because heat is a form of energy. Okay, if a form of energy, and then the manifestation of heat is of course the temperature, because we can feel that a certain object is hot or cold. Okay, temperature, the hotness and coldness of a body. So this is the manifestation of heat. And again, the common example of the transformation of heat is our steam engine. So let's say we have here or a steam power plant. So this is a concept that is applicable in our field. So let's say this is our boiler. So this is a pressure vessel, pressure device, and then the boiler is uh, filled with water. So nasa water, H2O, and then uh, we heat this water. So we have here a fire or a source of heat. Okay, we heat this, and of course the the chemical energy, since we are burning something. Let's say we have here a diesel fuel, wood or bagas. So we have here a chemical energy, a chemical energy possessed by the burning fuel, then converted into heat, and then this heat will transfer. So the transfer is here, transfer to our water. So that's why our water here will be heated up until it will change into steam. Okay, magiging steam na ni siya. Okay, mas steam na ni. Kung sa kuan pa singaw. And then this steam will be drawn towards our steam turbine. Okay, steam turbine. Let's say this is our steam turbine. Okay, and this steam turbine will convert, okay, the heat energy. So tungod kay, di ba, nagsunog man ta, so nata diri heat energy. So na heat energy nga gi-carry, okay, heat energy nga gi-carry sa tubig. Okay, mo nang ang tubig ang iyahang state karon kay high energy level na siya, since nakakuan mo siya, naka vapor state, misingaw naman eh. So kani siya nagbukal-bukal ni diri nya mga tunis siya sa, it will go to our steam turbine, and then since our water is at high energy level, so it will rotate this turbine blades, and then from heat energy maka-convert na siya into mechanical. Okay, because of this shaft. So from heat energy to mechanical energy. Then of course the final product would be the electrical energy from our generator. So let's say this one is our generator. So we have inside the generator the coils of wires. So we have our final product as electrical energy. Okay, so see how useful the heat energy. So this is the energy transformation wherein we can also observe the heat energy. So man siya gikan sa kaning chemical gida sa tubig. Okay, giprocess sa tubig ning kaning kuan heat energy, and then iya pod gi-transfer nga to sa turbine blades para mo rotate, para mag-generate og electrical energy. And another example pod of heat transformation is just by rubbing your hands. So imo na i-rub, so nakay ka nang nagduka og work, imo gibagnos-bagnos, and then you create friction, and then of course kanang friction, diba, sooner or later muinit imong kanang kamot, so naka-generate ka og heat. Okay, so again, heat is not a property of a material, but it will only uh, transfer from one material to the other. Okay, kay dynamic man ni ang heat. So let's proceed to the zeroth law. Okay, the zeroth law is uh, one of the laws in thermodynamics. So kanang prerequisite ni siya sa first law of thermodynamic. When we say zeroth law, it states that if we have a material A, okay, say if we have a material A at certain temperature, let's say this is TA, and then if we have another material, let's say B, we have a material B, and then at a certain temperature pod nga TB, and then another material, let's say material C, TC. Now here the zeroth law states that if material A, so this one right here, is in thermal equilibrium with material B, so when we say thermal equilibrium, meaning wala na heat nga may transfer, diba? In the previous slide we're talking about the transformation of heat kanang heat energy. So here wala na transformation of or transfer of heat kanang kwan energy, so therefore ang ilahang kwan temperature nini, if they achieve thermal equilibrium, so magiging kwan na siya, magiging TA equals TB. So it would now become TA equals TB. Okay, again, if both A and B are in thermal equilibrium, so their kwan temperatures are the same, TA is equals TB. And then another thing also, and if material B, so kanina po si material B and material C will come into contact, and then they achieve thermal equilibrium. Okay, meaning ang ilang temperature may approach na po to a certain value, so meaning equal na ilang temperature. So therefore we can also say that if that is the case, so we have here TB, the temperature of B is also equal to the temperature of C. Now from these two equations, so we have here temperature of A equals temperature of B, and then if the temperature of B is also the same with the other material, which is material C, therefore we can also say from by zeroth law, okay, by zeroth law we can also say that A is also, of course, understood na si A is also in thermal equilibrium with C, okay, TA equals TC, because by looking at the equations ato kitaon mathematically ato ma-prove nga of course si TA pod is also equal to TC, and we can apply this in our glass, in our thermometer. So let's say here nagsukod siya ni A, okay, nagsukod siya ni A, then ang temperature reading ni A kay 22.5. okay, so you can see we have here a thermometer, and we have here material A, and then the reading of material A is 22.5. Of course we have another material which is our thermometer, so this is our thermometer and this is our material C. Okay, thermometer. Of course kaning tip sa thermometer, ang temperature ani og ang temperature pod sa surface aning material A of course the same, kay para ma-read niya mo na gitawag nga thermal equilibrium. And then misukod na pod og lain si thermometer, same thermometer gihapon gigamit, then misukod siya og different material which is material B, and then it was found out that ang reading sa material B is the same reading sa material A. 22.5. And then since they're using the same thermometer, therefore we can say that A is also in thermal equilibrium with B, and the same with the kanang probe sa thermometer kani siya si same na sila og reading. So manang zeroth law. Now if mura na siya og kung si A kay ang temperature sa A kay equal ni B, and then if B is equal ni C, so therefore A is also equal to the temperature of C. So the other way around. This is uh, the definition of the zeroth law, and we can apply this by deriving the basic temperature scales. Okay, so next one, I'm going to jump to the temperature scale. So as what I have told you, the manifestation of heat, so ang kainit, uh, actually ang iyang manifestation is masakod, because when you say temperature, that is the kuan, di ba? When you say temperature, that is the hotness, okay, hotness and coldness of the body, okay, of the body. But actually that is only for uh, the kuan macroscopic nga kuan niya definition. So this is only for macroscopic nga kanang kuan definition, meaning at a larger scale. Okay, kay maka-define po ta sa temperature in a microscopic level, because another definition for temperature is that is the kuan the total kinetic energy, or I think the average kinetic energy. Okay, the average kanang kinetic energy of the molecules inside the body. Okay, of the molecules inside the body. Of course, because kanang mag-interact mo na, especially if kanang kuan naa kay gi-input nga energy. So let's say imong gihapak, consider this, let's say these are molecules in a solid material. So mana siya na siya arrangement niya na. So if we excite this one, let's say ato siya hapakon, so you have an applied force ato hapak, so therefore kani siya each molecule here will vibrate. So mag-vibrate ni siya, and of course it will bombard with each other. So unsay ma-produce is natay energy ni ani, and then ang pagsukod ni ani tungod kay nag-grab man ni siya, so there is a friction and collision na exist. So therefore ang totality ni ani is mag-create siya og heat. Okay, and then masugod na to ang iyahang average kinetic energy in terms of its temperature. Okay, temperature. So that's why we have temperature scales. So sa mga temperature scales, these are units used to measure kanang temperature. So we have two temperature scales. Okay, basic. So we have the first one, we have the Celsius. Okay, and then the next one is we have the Fahrenheit. We have the Fahrenheit. So man siya Fahrenheit. I'm not sure with the spelling. I think man siya Fahrenheit. So Celsius, this is kani siya murag metric unit. Okay, Celsius is for metric system. Okay, metric system. And then ang Fahrenheit kay murag imperial unit ni siya, or English unit. Okay, imperial unit. And here we are going to want to determine the relationship that exists between these temperature scales. So it is very important, especially in solving problems. Let's say if you're given a Fahrenheit, and then the required in the problem is the required answer in the problem is in Celsius. So what you need to do is you're going to convert Fahrenheit to Celsius. So mana imuhang button. So how are we going to derive this? And also additionally, from the Celsius scale we also have another scale aside from this. So sa Celsius, we can relate to its kanang murag counterpart nga kanang scale makitawag nga Kelvin. Actually the same ra sila og kanang kuan, the same ra sila og graduation. Medyo dako-dako lang si kuan, dako-dako lang si Kelvin. And then here for Fahrenheit we also have an equivalent scale, which is the kuan, the Rankine. Okay, Rankine. So mana siya. For Celsius we have Kelvin, also for Fahrenheit we also have Rankine. So let's start with deriving the relationship that exists between Celsius and Fahrenheit. So for Celsius and Fahrenheit, we are going to base our derivation from the working substance, which is water. Okay, mag-base ta. Diba we all know that water, okay, sa may properties of wet sa kwan sa water nga atong ma-apply in terms of its temperature. So we all know that at freezing, okay, at freezing, we'll know that the temperature of water at freezing is equal to 0 degrees Celsius. And in Fahrenheit, we all know that this one is 32. Okay, 32 degree Fahrenheit. So mana siyang condition at freezing. And then at boiling, okay, at boiling meaning nagbukal. So at boiling, of course, we know that one, that the boiling temperature of water is at 100 degrees Celsius. And in terms of Fahrenheit, we have 212 degree Fahrenheit. So these are just the two things you need to remember in deriving this, because if you have this, then we can say that we have here, let's say we're going to transform this one into coordinate system. Let's say we have here 0 and 32, and then this one also we are going to make it as 100 and 212. So therefore here we rewrite this data into coordinates. So from this coordinate we can say that our abscissa or the x-axis is our Celsius scale, diba? Celsius scale. And of course our y-axis, which is our ordinate, is the Fahrenheit. Okay, the Fahrenheit scale. So we are going to draw the Cartesian coordinate system here. So Cartesian coordinate system, so this one, and then we are going to plot these coordinates. Okay, so the first point is 0 down, then 32. Let's say this is 32, so this is 0 and then 32. This is the first point, and then we're going to locate the second point. Let's say the second point is somewhere here. Let's say this one is 100 and then 212. So meaning this one right here is 100 and then this one is 212. So this is for Fahrenheit. And then the x-axis again is for Celsius. Okay, degrees Celsius. So in this Cartesian coordinate system, then we can draw exactly a straight line. Okay, because the relationships sa temperature sa kanang Celsius of Fahrenheit is linear. So linear, yeah. So therefore we have here a line, and as you can remember in your analytic geometry, so if we have 2 points, so we can generate an equation of a line, right? So maka-generate ang equation of a line. So generating an equation of a line, so here we can say that if we have kanang 2 points, so we can use the 2-point form. So we have here y minus y sub 1 is equals to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1 multiplied by x minus x sub 1. So we can just choose y sub 1 and x sub 1, either of these two. You can have this 032 or you can have 100 and 212. So here, this one right here, can you see in your notice, can you see this is our slope, right? Diba? The slope is change in y over change in x. So here we can substitute the values. So y minus, let's say I'm going to pick this 0 and 32. So y sub 1 here is 32. So here we have 32, that is equal to, let's say our y sub 2 is the second point, this 100 and 212. So therefore y sub 2 is 212. This is for Fahrenheit. Minus y sub 1 is 32 all over x sub 2 is 100 degrees Celsius minus 0, then multiplied by x minus, since we are choosing the first point as 0 and 32, so therefore the x here is 0. So 0 na siya. So simplifying, so we have, okay, here let's just change these x and y in terms of degrees Celsius and Fahrenheit. So y is for Fahrenheit, diba? Degree Fahrenheit minus 32 is equals to, here this would be 180 over 100, okay, 100 multiplied by degrees Celsius. So we can transpose this on the other side, so we now have degree Fahrenheit is equals to, here this would be simplified into 18 over 10, that is 9 over 5, that is 9 over 5 degrees Celsius plus 32. Okay, so this would be the relationship that exists between degree Celsius and kanang Fahrenheit. Now if you're going to convert a certain temperature from degree Fahrenheit to degree Celsius, so you can use this one, and of course you can also use this vice versa. Okay, gamit niya po niya, and then modifying this equation, you can have degrees Celsius as a function of degree Fahrenheit. So common lang bahala sa pag-derive. So this is the relationship between degree Fahrenheit and degree Celsius. And now ato na po i-discuss ang relationship between katong ilang corresponding nga mga temperature scales. Katong for degrees Celsius we have Kelvin, and degrees Fahrenheit we have degree Rankine. So let's start with Celsius and Kelvin. So ang atong kung naikuan ang say kalahianan ni, actually ang Kelvin man siya ang absolute temperature scale. Okay, absolute temperature scale. When I say absolute temperature scale, true gud ang value niya sa 0, kay when we say 0 degrees Celsius good, hindi man na siya ang absolute nga 0, because di ba ang equivalent ba sa 0 degrees Celsius kay napay 32 degree Fahrenheit, so di siya ang pinaka last. So mo nang si Kelvin ang pinaka absolute, because when you say 0 Kelvin, so wala na yung mga thermodynamic processes nga may tabo, since naman like very low energy na kayo. So that's why si Kelvin ang gi-considered as absolute temperature scale. So unsa may relationship nga nag-exist sa Celsius and Kelvin scale, so we have here degree Kelvin, or just write Kelvin is equals to degree Celsius plus 273.15. Okay, man siya. So let's say if we have 100 degrees Celsius, so the resulting Kelvin scale would be 373.15. So man siya ang relationship between Celsius and Kelvin. And then the next one, that is for Fahrenheit. Okay, so for Fahrenheit and Rankine, so si Rankine na po siyang absolute temperature scale for imperial units or English unit. So here the relationship that exists between them is Rankine is equal to degree Fahrenheit plus 460. So mana siya class. Now if we have degree Fahrenheit equals to 32, so the resulting value of Rankine is 492 na siya. Okay, 492 Rankine or degree Rankine. So muna siya ang atong mga temperature scales. Now we move on to the next topic, which is heat transfer. Okay, sa heat transfer class, muna siya ang mode sa uh, sa pag-transmit sa heat from one object to the other. So we have three modes of heat transfer. Okay, we have three modes of heat transfer. The first one is we have conduction, and then the second one is we have convection, then the third one is we have radiation. So ato na siya tagsa-tagsaon, and then here I am going uh, uh, to discuss the definition of these three modes of heat transfer, and also their formulas. Okay, natay drive ng mga formula mo na importante because uh, mag-solve man ta mga problems nga related ni ani. So let's start with the conduction. Okay, muna siya ang pinakauna, ang conduction. Okay, so when we say conduction class, this is a heat transfer that exists uh, among solids. Okay, this is for solid matter. Okay, solids. But however, in some cases class, we can also experience conduction heat transfer in in fluids, like in liquids and gases, if kanang kuan given ang certain mga conditions. Let's say if ang air kay wala gyud nag-move, still air kayo, so therefore mura siya og kanang ma-assume nga conduction ang mode sa heat transfer only in that case. But naturally, since ang air around us is moving, so lihok man, so therefore di na siya matawag nga conduction. So mostly gyud common gyud nga sa conduction application is for solids, because the conduction, this is the heat transfer. Okay, heat transfer ni siya nag-exist between molecules that bombards, okay, that vibrates each other. Okay, so mas advantage kay solid, since ang solid ay ang molecules kay tightly packed together, so therefore if you're going to vibrate the outer part, so kana siya mo transfer na siya towards the inner. So that's why if you're going to apply heat sa outer nga part, din kana pud heat nga heat energy mo cause na siya o vibration. So we're going to illustrate that one. So let's say this is the representation of our solid molecules. Okay, mo na siya. And since this is heat transfer, so let's say natay gi-input diri. Okay, natay gi-input diri nga nga heat energy. That's why it causes some vibrations inside. So we have here heat energy. Okay, so this heat energy will be transferred from this side, let's say this is side A, to side B due to the excitation and vibration of each molecules here. So kaning nga molecules, say kanin siya mo vibrate, so mo transfer sa usa diri na pod, mo katay din diri na pod, maguyog-uyog ba adto diri. That's why side A at first becomes hotter and hotter until si side B pod mainit pod because of this heat transfer via conduction. So again, conduction happens by kanang molecule to molecule interaction and vibration. So mana siya, that is for kanang solid. And then unsa may mga material nga kusog kay mo conduct, so the materials that has high conductivity, so mana siya mga metals. Okay, metals. So unsa man ang metals kanang aluminum, we have steel. That's why kanang ato ang mga frying pan made of metal na siya para kusog ang paggandak sa heat labi na magluto ta, so mainit dayon. So mana ang reason nga kana ang gigamit tungod kay kusog kay mo kandak ang kanang kuan metal. So mao nang magpainit kag metal like this one. So ako i-drawing ha. Let's say there's a fire here. So na ay fire, let's say bonfire, and then ikaw nagunit ka og kanang kan steel rod. Let's say this is a steel rod. So can you see, of course it will get hotter here in this part. So mainit ni diri, and then of course kaning init kay via conduction mo ay inihinay ni og kanang kandak mo transfer hantod nga at a certain point of time maka-feel ka nga oy miinit naman po diri nga tip because saturated na diri. So ang heat kay mi transfer via conduction inside or within the molecules of this steel bar. So ano maka-feel kag heat because of kanang conduction. So ingana na ang basic principle sa kanang conduction. And for conduction class, of course syempre nagana siya ay formula to calculate the rate at which conduction happens. So for the conduction, yung formula kay nagikan sa gitawag nga Fourier. Okay, Fourier's law. Okay, Fourier's law. And Fourier's law states that let's say if we have a certain material, not a material ha. We have a material, and then I'm going to label this as side A, and then this one is side B. Okay, so si side A, there's a source of heat. Okay, there's a source of heat here. Okay, so meaning side A is hotter than side B. So we can also denote some temperature here. So let's say this is temperature A. So this is TA, and of course this one right here is TB. So again, initially, of course, TA, since naman diri nga side ang source of heat, we have here a source of heat. Init ari. So therefore, si TA mas higher iya hangkuan, mas higher iya temperatures. Therefore, we can say that TA is greater than TB. Okay? So if we have a temperature difference, so meaning mas taas ni si TA ug si TB, of course, normally yun ang kainit sa kuan sa material mo transfer yun ngadto sa bugnaw nga part. Okay? Di pod pwede pod ng init mga tupigid sa init. So normally ang init mga to sa bugnaw. So therefore the flow of heat transfer here is from this side, then it will go to here inside this material. So makandak siya via its molecules, so bombardment, vibrations, mato na siya until malapos. And then we're going to calculate the kuan. We're going to calculate the heat transfer rate. Now in calculating the heat transfer rate, again we're going to use Fourier's law. So Fourier's law states that the rate of heat transfer, okay, we have here Q. We're going to represent this one as Q. So Q is equal to the thermal conductivity of the materials. So meaning kani si material nag-possess ni siya og some properties, and we're going to label this one as K. Okay, and by according to Fourier, ang iyang formula is negative. Why? Because normally ang heat man good is from higher temperature to lower. So kanang iya gibutan og kuan negative. Anyways, if ang problem nimo nag-ask sa heat rate, so you can just take the absolute value. So here for Fourier's law, so we have here negative K. Again, K is the thermal conductivity, and then also the rate of heat transfer is also proportional with the area, exposed area. So the exposed area here is this side. Can you see? More siya exposed area. So we have here area, and of course the last one is the rate of heat transfer is also i kanang kuan related to the length of the material. Of course, conduction man ni siya class, molecule to molecule man siya. So the farther you are, so kanang the longer it takes to conduct. Okay? Mas kuan as what I have kanang given you an example a while ago katong na bonfire niyan imong gidip ang katong steel rod nga sa bonfire. So if taas to nga rod, of course mas dugay siya nga ma-feel nimong init, whereas kung mubo siya, so mas dali pagkanak. So therefore naay relationship nga nag-exist between the rate of heat transfer and also the length. So by Fourier, again, the relationship is directly proportional to the thermal conductivity and then the area, but inversely proportional with the length. So again, mas paspas siya kung mubo. So kung mas taas gali ang length, so meaning mas hinay siya. And then of course, the change in temperature. So again, heat transfer only happens if there is a temperature difference. Mga ganun yung nauna-on. If there is a temperature kind of difference, so therefore heat transfer happens, especially for conduction, and not only conduction but the remaining two nga mga modes of heat transfer. So again, nagyud kay temperature difference. Now, what happens if si TB mo equal ni TA? So meaning wala na conduction mahitabo, saturated naman siya, so init naman, so there's no need to transfer heat pa. Doon kay taas na ang pikas. So mala siya gitawag nga thermal equilibrium na achieve na. So again, mora ni siya ang formula for conduction, and by unit analysis, importante pud ni unit analysis, ato kita unsay kanang units ni. Now for Q, since this is heat transfer rate, so this is in watts. Okay, that is in watts, or that is equal to joules per second or per unit time. Okay, so medyo bias ko sa kuan. I'm using the metric. So for the thermal conductivity, actually the the unit for thermal conductivity is watts. This is for metric ha. That is watts, then per siya, per meter. Watts per meter, then Kelvin. Okay, that is for thermal conductivity. And of course, for the area, we'll know that area is in meters squared, right? Then divided by the length, that is in meters for metric. And of course, the change in temperature, we can have degree Celsius or degree Kelvin, it's up to you. So let's just put here degree Kelvin. And here, let's try kung sa resulting nga kanang units if we're going to manipulate the right side. So here, meters, then ay meter squared, so makuha ang usama meter na lang, and then of course meter sa numerator and meter in the denominator, this one will be cancelled. So makancel na po na siya. And then of course this Kelvin here and here makancel. So therefore what's left is watts. So therefore on the left side we have watts equal to watts. So again, don't forget the units for thermal conductivity, that is in power per meter length and temperature, and area is of course meter squared, length is in meters, delta T is in Kelvin, or you can have degree Fahrenheit. It depends upon the problem. So again, don't forget this. Imagine ang inyo kalimtan gamit kan especially in higher subjects, the Fourier equation for conduction. Q is equals to negative Ka L delta T. Okay, and by having this, so we also have some kanang class. We also have some formulas we need to take regarding with conduction. Okay, regarding with conduction. What if class? Okay, what if we can model our heat transfer into an electrical circuit? Okay, into an electrical circuit. Let's say, diba, as you notice, by Ohm's law, okay, by Ohm's law, diba, we know that Ohm's law, the relationship is we have the voltage V is equals to IR. So this is voltage, the driving force, and of course this is the current. So muna siya ang the flow of kanang charge, and of course we have here the resistance. So muna siya nag-resist sa pag-flow sa current. So therefore the current is inversely proportional with the resistance. So this is for Ohm's law. But for Fourier's law, katong atong law of conduction, ato is watog balik. So Fourier's law, so we have here Q. Q is equals to this is negative Ka L delta T. Okay? Now, diba, as you notice, the I here from Ohm's law, I is the current, that is the flow of electrons or the flow of kanang electrical charge. For the Fourier kaning sa conduction, unsa may ni flow, nabay ni flow. So we can relate di ay nga si current is the same as in Fourier's law, that is the heat rate. Okay? Or the heat transfer rate. So kani siya money. So kani siya, you can model this one as for current. Ato i-model ha unsay katumbas or equivalence niya kung ato na siya i-model into electrical circuit current. And then of course we have here kuan siya delta T. So meaning kuan kanang delta T, this is kuan temperature gradient or temperature difference. Of course si voltage na definition si voltage ang gitawag nga potential difference. Okay, potential difference, or sa tubig pa, this is kuan pressure difference. Okay, tungod if you have a given circuit, okay, one circuit ha, then we have here a source, and then of course we have here a source of power. This is 5 volts, and then na ay nagtuyok na current. Of course, let's say nag-add lang ta nga, there is a resistance in our wires, so we are going to represent this as our resistor. This is R. Okay, so this is our voltage, positive, negative. Now mo gana ang battery, if dako pa kag potential difference, meaning maka-flow pa kag current. Now if wala na kay voltahe, di na ka maka-flow og current, man ang uban battery ma-weak. So here in our Fourier's law pod, ang delta T mo ni say magpareha sa battery kaning source of power kaning sa voltage. Why? Because if you have a greater temperature difference, so meaning dako pod ang pag-flow sa imong heat, mo ni dako pod imong heat rate. Now kung saturated ang temperature, meaning the temperature difference is 0, so meaning equal na ang temperature, so what na flow. So therefore we can relate the temperature gradient into voltage. Okay, voltage ni siya ngadto sa kaning Ohm's law. And then una may lain, the last one is this one, this thing right here, and we can represent this as the resistance. However, in the Ohm's law, nagtapad si resistance og si current. So therefore in order to resolve the Fourier's law into Ohm's law, ayan porma kay naka Ohm's law na, so therefore we can modify this equation. We have here delta T is equals to Q, then ato na siya i-transpose diri, we can multiply both sides by negative L over Ka. Okay, negative L over Ka. So therefore this is Q times negative L over Ka. Or we can just represent this negative L over Ka expression into R. Q multiplied by R. Meaning R here is the resistance. Okay, the heat resistance. Heat resistance in conduction. Okay, this is for conduction only. So heat resistance. So therefore, if we're going to analyze kanang conduction yung mga problems, ato di siya ma-model into an electrical circuit. Okay, because in this way ato makasolve ta og kanang composite materials. take for example take for example we have here a source of energy, source of heat, not a heat source area. And then we have some materials nga dool niya. Let's say we have the first one, material A with thermal conductivity key A, and then tapad po the material A, another material po we have here nagdikit si material B, so this would be the thermal conductivity is KB. And then we have a last material KC. We have here KC. So here we have a composite material already, and of course na gina say temperature. So we have here T1 for this side, and of course T2 for this side. Now given or assuming that T1 is greater than T2, so mas init ring side, and then we also have here an area, heat transfer area, and then since uniform sila, so same as like area but they have different lengths. Let's say this is for the length of A, length of B, and then length of C. So nagkalaylay sila length, nagkalaylay sila og thermal conductivity, but they are of the same area. Now heat flows of course from the first material, so from key A to key B and then to key C and then pagawas. So ato pangitaon ang heat transfer rate from this side T1 until this side T2. Of course ang kuan ani ang principle ani is ma-apply na punta sa katong sa electrical circuit katong series of parallel nga circuits. Okay, series and parallel circuits. As you notice here, of course ang heat rate nga mo transfer ni key A, that is QA, is just the same as QB tungod kay series man iya connection, and then same na po ni QC. So therefore, since Q represents current, we can say that at this point we can draw a heat diagram or an electrical diagram, heat diagram. And the heat diagram starts with point 1. Then we have here some resistor nga mo represent nga naay resistance dira. And then for a second object, another resistor or resistance, the third, and then last. So this is at point 2. Again, we have here T1, the temperature at point 1, and T2, the temperature at point 2. So here, diba, natay Q. That is for the current. So we have here Q. And then, diba, we have a voltage drop here, or in terms of the heat, that is delta T. So of course, we have delta T. That is equal to T1 minus T2. Okay, starts at 1 and ends at 2. How about for R? So since they are of the same, are of different material, so this, the first one is we have for RA, that is the resistance for A, the heat resistance na siya, and then this one is RB, the heat resistance for B, and then the last one is we have the heat resistance for C. So therefore, since this is series, so diba, ma-generate na itong equation for current, diba, current Q. So this is what, that is current Q, diba, current, we all know that current I equals V over R. So what is the voltage again sa atong heat transfer area? So that is the delta T, the temperature gradient. So we have here voltage delta T all over the resistance. That is, since this is series, so for series connection, that is the total resistance is equals to R1 plus R2 plus R3. Sum up na nato, okay? So that is RA plus RB plus RC. And as we all know, ang formula for resistance, okay, that is negative L over KA, okay? Negative L over KA. So since this one right here is negative, so we can just ignore this. Okay, the same run sila, or just take the absolute value anyways wala man po yung mausab since unidirectional man na siya. So we now have negative t, or we can kuan pwede po ito i-keep ang negative, so let's just put it in the numerator. So for RA we have the length LA over key A and then the area, plus for RB the resistance, the heat resistance is the length of B over the thermal conductivity B, then A, plus the length of C over the thermal conductivity of C and then the area. So this would be the rate of heat transfer for composite materials. Now for composite materials nga naka-arrange siya in series, because there are some composite materials nga naka-arrange in parallel. And then ato kitaan kung sa to siya sa pag derive po dato. So let's say another case na po. So this is for this is for series. Okay, this is for series connection, series connection for composite materials and heat source. How about for parallel? Let's say we have again a heat source, not a heat source and then I have here the first material. Okay, naka first material, and then napag ikaduha, and of course nasyalay this is key B, and then the first one is key A. Of course si key A na po siya area A, so it has an area, this is area A, and then of course si key B lahi siya area po, that is area B. And then let's say pareho lang sila og length. Okay, let's say they have the same length. And then of course sa left side na ay temperature 1, and then hotter than the other side, temperature 2. So therefore na heat nga mo flow from here to there. And then since duha iya ma-flow nga heat, meaning from heat source, matunga siya so ma-split din siya. So ma-split na siya since nakaparallel naman ang kuan. So the heat source, ang amount of heat niya mabahin padung siya sa material A, and then ang usa padung sa material B, then balik na pud usa na sila. So therefore naatay parallel connection nga nag exist. So if we're going to convert this into heat diagram, it will now become, so this one first point T1, and then split man siya, so this is the resistance for material A, and another one resistance for material B, and then they come up with the same temperature. So this is T2. So here naatay mga resistance. This one is for material A, that is resistance A, and then this one ang ubos, that is for resistance B. So here we can use the Ohm's law, that is for heat ang voltage, di ba? Atong voltage is ang kuan, our voltage is the temperature, so that is delta T. Voltage equals to kanang IR, that is the current. So our current here is Q, then our resistance is the R total, that is in parallel. Since nakaparallel man siya, okay, nakaparallel man siya, so therefore what is the total resistance for a parallel connection? So for a parallel connection, we have here R total is equals to RA times RB all over RA plus RB. Actually nakaderive ni, pero naggikan gina siya sa relationship nga 1 over R total is equals to 1 over RA plus 1 over RB. Nga na siya, class. So here nakaparallel man siya, no? So we're going to solve for Q. Okay, ato i-solve si Q ani. So therefore Q is equals to delta T all over R total. And R total, as we know, so si delta T, that is T1 minus T2 all over, that is RA RB all over RA plus RB. Now substituting the values or the parameters nga naa sa materials A and B. So material A, ang say formula sa resistance, that is L, since same rows like L, so we just represent this as L over key A, then area A multiplied by RB, that is L over key B, area B, all over L over key A, area A, plus L over key B, area B. Actually, we can cancel one of the L's here, so the final formula would be T2 minus T1 all over this one. It will now become 1 over key A, area A, then key B, area B, all over 1 over key A, area A, plus 1 over key B, area B. Or you can also simplify this, but anyways, it's up to you na lang. So muna siya for parallel ni siya, parallel nga orientation sa mga materials. Now ang mostly gigamit ani kay ang series. Why? Ang series gamit ni siya sa asaman. So for series or for composite materials arranged in series, gamit ni siya sa walls, especially sa mga temperate zone, mga houses din to, tungod kay sa ilahang balay, ang ilang wall is naka-layer na siya. Let's say the first layer is the layer of concrete, then the second one is naka fiberglass sheet. Kaya naman siya, this would serve as an insulator para di siya mo bugnaw jud kayo kung winter, di po siya mainit kayo kung summer. Muna siya naiuban tinagtulo or tinag-upat nga sapaw. So here makayunta nga ang arrangement sa material kay in series. So therefore we can use the series connection nga formula. So kanat siya for this case. Kaya ang transfer sa heat ani is, let's say this is the inside of the house, and then this is the outside of the building or your house. So let's say your house is more hotter, or your house is hotter than the outside, so therefore ang heat loss ana or ang transfer sa heat kay diba from a hotter body to a lower to a colder body, so that is from inside mo transfer siya, mo agi siya via conduction, mo pass to dire sa insulation, then mo gawas. So as you notice, kung baga mo insulation, mas dugay mo conduct. And then especially kung gamay gud siya thermal conductivity, ha, kaya diba from our formula for thermal conductivity, diba, kung mo gamay ni siya, mo drop ni siya, automatic mo drop pod ang heat rate. So manang they use some insulators because insulator is a good resist kanang kuan, good na siya nga resistance sa heat. Okay, insulator. So mao nang ang uban magbutang og insulation para mo block siya sa heat, mo slow down ang pag-transfer sa heat. So again, don't forget with this one kay magkanta ni mga sample problem. So this is for series because kung magsalig ra taning single nga equation, so kamo na magutaan ni sayo na kay ni kaning sa Fourier. So again, Q is equals to negative key A over L, so the length of the path of conduction, then change in temperature. Again, para maka-solve tag problems nga composed of two or more materials arranged in certain arrangement, let's say parallel or series, then man na siya mga formulas niya pag-derive niya. So dapat kay ba ka mo interpret sa heat diagram. So ang pag-relate nimo ana is mura siya sa concept sa electricity or sa electrical circuits, I mean. So gamit ang Ohm's law, we're going to relate the voltage as the temperature difference, the current as the heat rate, and the resistance, which is the ratio of the length of the conductor and its thermal conductivity and the area. So this is for conduction. Now let's go to convection. So take note with this. So say raise. So the second one is convection. Now for convection class, this is the transfer of heat mostly for fluids. So what are fluids? These are liquids and gases. So sa tubig o sa hangin, liquids and gases. So sa may kanang convection, sa iyang murag kanang iyang kanang mechanism. So for convection, mo siyang ang transfer of heat from kanang liquid molecules, and ang iyang manifestation ani is that we have a kanang difference, okay, difference in fluid kanang density, difference in fluid density. Kaya nga naman, let's say good example ni is that let's say I have here a bowl, okay, or ipan, I mean a pan, tapos sunod sa pan is we have here a water. So mura tag nagpabukal tani, and I have here a source of heat. Okay, I have here a source of heat, so ato siya giinit. And as if notice class, kaning tubig sa ilawom, so kaning tubig sa ilawom na siya na if we're going to zoom this, let's say mo ay nahitabo sa sulod. Okay, na tubig dira, na tubig. And then since ang heat kay nasa ilawom, okay, the heat is kanang under the frying pan. Pagbukal nato, di ba? Na conduction na itabo again, na conduction somewhere here, from here to here, di ba? Kay namni wall sa frying pan. So from conduction, ang next sa conduction is convection na, because the sana ang medium na diri is fluid naman. So the solid is only here. So this is conduction here, kay solid man siya gikan sa heat source But in order to heat up this water inside, the mode of heat transfer is convection na. So unsa ang pag-init niini? Unsa ang pag-init sa tanang tubig? So mo ang working principle sa convection. Diri pag-transfer sa init class, actually sa molecules tungod kay high energy level na siya, will go upwards. Okay? Go upwards. Kana sila mga high energy level na siya. High energy level nga mga molecules, water molecules. And of course, kaning colder diri nga mga water molecules kani diri babaw, mo sink ni siya. Why? Because much denser ba kung bugnaw. So kung mas bugnaw, mas bugat ang molecules. Kung mas init, mas gaan sila. So naay difference in fluid density nga nitabo. Why? Because kani siyang high energy level nga mga molecules, this one is already less dense. Okay, mas gaan siya. But this low energy level nga mga molecules, so this is low energy level, kani siya more dense ni siya. Okay, more dense. or mas denser ni siya. So therefore na ay difference in fluid density, and by this mechanism, so kani nagrotate siya. Okay, nagrotate ra ang ang colder water kay mo sink, ang hotter water mo goes upward. So that's why there comes a time nga saturated na gali, init na tanan, so naanay singaw, mo nang mubukal na naanay steam nga mo gawas, because ang high energy level sa water nako-convert na siya, na-vaporize na siya, na-convert na siya into steam, which is very high na jud kaayo. Okay, so man siya ang convection. So due to the difference in fluid densities, and of course we can also observe this in our environment. Okay, sa ato environment, let's say sa ato ang kaugalingon nga landscape, let's say na mountain array, and then sayang kuan kay na dagat, so na dagat. Okay, diba, sa ato pod kuan ng kuan water cycle, so mao nang inigbuntag, sa inigbuntag, okay, inigbuntag ha, ang init, so mo rises up ang kuan, let's say we have here is sun, so heat source ani, let's say natay adlaw, heat source na to. Okay, we have here a heat source, and then tungod kay heat up siya sa yuta, so therefore ang air molecule, so kani siya is for water, here for gases na pud. So ang air molecules ani kay mo rises upward. Okay, mo rises upward, so therefore high energy level na pud na siya. So ang air density mo musaka, and then tungod kay init na ang yuta, di ba, mas dugay biya painiton ang bodies of water kaysa sa land. So therefore sa land na upward movement sa hangin. Okay, so that's why maka-feel ta og sea breeze. Okay, mo nang naay sea breeze, nga mohuyo pa dong inland. Okay, so naay sea breeze, mo nang ang init musaka, and then sa may bodies of water, of course ang cold air nga nasa atmosphere mo go down na pod. Okay, so mo go down, and this cycle repeats again and again until nga during kanang at noon time init na kayo, tungod kay inanay hinay ang pag-transfer sa kuan. So naay kanang kuan temperature, I mean kanang difference in air density. So here we have low dense, tungod kay high energy level na siya, and then this one is high density, tungod kay cold air pa na dira. So nagrotate ra siya, so manay manifestation sa pag transfer sa heat via convection. But here kana ko ipagkita ninyo, actually kani siya man siya gitawag nga natural convection. Okay, natural convection. Why? Because ang gigamit na to ani is kanra via nature na temperature difference tungod sa heat source. So let's say kaning sun, mararaga tong gibiyaan ba, naghatag ratag heat source, then ato siya gibiyaan nga ang densities nila kay magkalaylay hangtod nga mo init gid sila. So ato gibiyaan nga mag-cycle up sila, nga ang cold air mo go down, hot air kay mo musaka. So ato sa gipasagdan wa tay gigamit nga bisag unsa para mo aid sa kapaspason sa pag-transfer. But there is another type of kanang convection, and we call this one as a forced convection. So here naa na tay gigamit nga murag panabang para mapadali ang kani siyang heat transfer nga process for convection kay sa natural convection mo good hinay ni siya so slow process ni pero mainit gid hapon but for forced convection mas paspas ni why sa forced convection so here is a basic uh, nga pagkanya pag illustrate let's say a best example ni is sa inyong hair dryer so in your hair dryer actually sa sudan na natay coils of wire okay we have here coils of wire ano na siya sa hair dryer so of course kanin siyang coils of wire mo na siya to heat source okay ato i-erase ato siya ibalhin let's say na tayo coils of wire na siya so this would serve as our heat source connected man na siya so mainit na siya mainit na and then of course naka-tunnel ni okay naka-tunnel na siya diba sa blower nato na siya murag inside the tube so nagana then of course money ang gawas so natay heat source and then before aning kaning coils of wire natay diri fan diba muyop naghangin so natay fan dira of course in the process of kanang forced convection so ang hangin so the air here so enter ani nga fan kay na may suction effect nga mahitabo so air in of course kanin siya kaning hangin diri so sod siya of course ang iya density is low so low iya density so low rho nya diri pag sod niya gihuyop siya so mga to siya ani nga heat source okay mga to siya ani nga heat source now kadyo nato mapainit ang sa gawas tungod kay gipaspasan man tungod aning fan so natay gi-incorporate nga fan para mamupaspas because ang output ani niya is mainit na so ang air ani kay init na siya so air will get hotter immediately because of the aid of this fan so mupaspas siya sa pag-touch sa heat source so man na siyang air out then low density actually high density din yung una sorry high density ni siya high density na siya mabugat pa na siya niya giidan og fan so manang miinit din siya so gamit kining forced convection para mapadali ang pag-init or ang pagbugnaw sa usa ka butang. And another example nini is that in our air conditioning system. So let's say we have here our room. So natay room ha. And kay bawo mo sa reason why gikabit ang aircon sa babaw. So tungod niini, tungod sa kaning sa kanang convection. So let's say here this is our air conditioning kanang unit so natay naibuo din and then naay fan nya kani siya kay actually kani ang kaning magkuan actually dili siya heat source actually kana siya cold din siya nga source kay man siya EHU okay so natay kanang kuan cooling coils so kani siya is cooling coil now kani nga room so assuming nga ang room kay at a certain temperature TA so mas bugnaw pa siya so let's say I mean init sorry so kani init kayo sa sud so TA very hot so of course diba ang diri ang mga molecules nga init kina sa babaw diba kay since they're hotter, so na sila nagstay sa babaw. However, sa kuan katong mga kuan bugnaw nas ubos. So na sila sa ubos ha. And di ba, ang goal sa air conditioning is of course mapa-lower ang temperature para maka-achieve tag thermal comfort. So ang flow ani is that since ang location sa atong air conditioning unit kay nasa babaw, so, diba, this is our AC unit. The location of our air conditioning unit is nasa babaw sa room. So ang circulation unit is that muuna ni siya. Since naman sa babaw ang mga kanang hotter air molecules, so sila yung muuna nga mo ngadto, musulod. Then with the aid of the fan, mapabilis. Since mo pass siya sa cooling coil, what happens is that bugnaw siya. So magawa siya, bugnaw na siya, then mo drop siya. Muna mas dali ra ni nga process. Why? Because ang cold air automatic mo ato sa ilawom. So this cycle repeats until ma-dominate ang cold air since gibalik marabag gi-flow na pud ang nasa babaw, ang hot air ngitra pud suksok sa babaw, then gi-pass through. So with the help of this fan, mo na siya ang example sa forced convection tungod aning aid sa fan, mas mapadali ang transfer sa init gikan sa kaning cooling coil padong sa kaning room. Okay, so diri kani siya, there comes a point nga bugnaw na ang room. So mo nang matabunan na ni tabunan, so bugnaw na ang room, wala na init nga air molecules nga present tungod ani gi-repeat mo ang process, gibalik-balik siya enter sa air conditioning, gibuga. So, mo na siya ang reason why na siya gikabit sa babaw, mostly gid sa babaw ang air conditioning unit para efficient ang transfer sa heat. So, mo na siya ang sa forced convection, and forced convection also happens in our environment. Let's say kana maghangin-hangin, di ba? Okay, makabantay mo mas bisag ang register sa temperature kay 19 degrees Celsius. Actually bugnaw na sa ato dire sa Pilipinas, bugnaw na. But if hangin, maka-feel ka nga mura mas lower pa, mas it felt like 15, chill kayo tungod sa kaning forced convection. Meaning, okay, kato siya, we're going to analyze that one. Let's say human body. So if naay hangin nga blow, this one is cold air. So naay cold air mo touch siya, meaning ikaw nga init ka, pabugnawon din kag dali niya kumpara sa way hangin. So kung nay hangin, mas kusog imong heat loss kay of course dadon man niya, di ba, para ba ni ba gidala niya. So therefore ang imong kuan na paspas kay ang pag transfer sa imong heat in the environment kung nay hangin, tungod kay si hangin nga cold mag-exchange ba mag temperature, di ba? Remember Zeroth Law, exchange mag temperature hantod nga in thermal equilibrium mo. So meaning sige pass through ang kuan, so sipo kag emit og kanang heat. So mao nang felt like kanang 15 degrees bisag 20 degrees ra ang naka-display sa thermometer. Okay? So makayon kang Allah, mas bugnaw pa man tungod ani. So mo na siya ang sa forced convection. Sa difference sa natural convection o sa kanang forced convection. And of course, the same with conduction, si convection na pa gitawag nga kuan. Na pa siya gi-follow nga law to represent its formula. Okay? Na pa ni formula ning kuan convection. So for convection, it follows the Newton's law of kanang cooling. So Newton's law ni siya. Ganiha again for conduction follows siya ni Fourier's law. So for convection, Newton's law. Unsa na po diya formula nini. So di ba, kato ganiha, if we have here Newton's law of cooling magod, if we have here some kanang water, so nakay air nga gipass through. Actually ang cooling effect niya according to Newton's law is we have here Q is equals to the heat transfer coefficient, convective heat transfer coefficient, HC, then the area. Okay? Directly proportional siya sa area. So kung mas dako ni nga surface ang tubig, dugay gid ni siya ma-cool. Pero gamay ra gali. Okay? Mas kuan, mas kaditra. So that is Q equals HCA then delta T. That is kung saan pasot aning delta T. So at the surface of the water, kay surface phenomena na siya, that is T1, and then of course the environment T2. Now in analyzing convection class, be sure to indicate ang sa surface gid because this is a surface phenomena and convection. Say pasabot niya ni sir. Let's say if we have here a wall, okay? We have here a wall and this is the surroundings. This is wall and then surroundings. Of course, ang una mahitabuan ni heat transfer within the wall, this is conduction. However, at the point nga kanay diba ang surface temperature sa wall, this is T1 and the temperature at the surrounding T2. Okay? Ang mahitabo nga heat transfer na ani from the surface of the wall to the surrounding, exposed in the surrounding is already convection. So again, walay mahitabo nga convection sulod sa wall because purely conduction na siya since this is solid. But in this case, since outside sa wall kay fluid naman siya, this is already a fluid, so therefore convection na siya. So again, take note that the delta T here is it's either the temperature of the outside condition that is surrounding and then the surface temperature of a certain material nga subject sa atong analysis. So here we can also use sa katong for composite nga kanang for composite fluids. Okay? For composite fluids, let's say ang fluid nga gi-stack say in series or in parallel. Okay? So let's say fluids at different densities. Let's say fluid A, fluid B, fluid C. Of course, napo na siya ay corresponding HC. A, heat transfer coefficient for B, heat transfer coefficient for C. Actually, the same as what we did. You just, let's say this is T1 and then T2. Let's say nag-init ta. Okay? Ato siya heat up. Of course, magbukal-bukal ni siya. So ang kuan ani ang overall convective heat transfer ani niya medyo complicated man ning heat convection mo nang gi HC lang siya. Unlike conduction na siya murag bag kuan ba. Na siya ay indicate properly nga man na siyang kuan mo na siya ang resistance niya in terms of the length and the thermal conductivity here directly ra siya proportional to the heat transfer coefficient. So that's why we can you can still use the principle for electrical circuit. So mara pod gihapon. This is T1 then T2, but this time this is RA, the resistance for fluid A, the resistance for fluid B, and the resistance for fluid C. And here, unsa man atong resistance. So the resistance here, the heat resistance here is equals to 1 all over HCA. Take note na ni siya because again, kung ato siya i-rewrite into kanang electrical circuit nga katong Ohm's law, that is delta T, that is for voltage, is equals to the current Q all over the resistance R. So therefore, resistance is Q over 1 over HCA. We're going to modify this now mo equal na po ni siya ani. So therefore, our resistance is 1 over HCA. Okay, gamit kay ni gyud siya class, especially for combination of conduction and convection. So the last one is the radiation. Okay, the last one is for radiation. So for radiation, radiation. This is the transfer of heat energy that does not depends with the with the uh, kanang matter, okay, without regards to matter, meaning bisag wala pa'y hangin, ang manifestation mo sa radiation is this is due to the electromagnetic waves. Of course, kaning electromagnetic waves nag-carry ni siya og kanang electromagnetic energy. Let's say, ang good example is ang atong sun. So, diba? Atong sun, and then layo kayo ang earth. Okay? Layo kayo ta, and how come nga ang energy gikan sa sun may reach sa earth? In fact, ang medium nga nag-exist between the earth and the sun is a perfect vacuum. Okay, this is a space. So vacuum kayo ni. So walay hangin, wa po'y conduction tungod kay walay rod nga nag-connect sa sun o sa earth. So therefore wala perfect vacuum. So walay matter. That's why radiation takes place. So for radiation, these are electromagnetic waves. So kana siya, since this is a source of heat, the sun is composed of hydrogen and helium. So kana siya mga elements, emit na siya og electromagnetic waves every second. So man siyang may emit siya. So mo radiate man ang term, mo radiate siya heat towards the earth, mo na makafeel ta og init. So mo na siya ang kwan. And then of course, again, since this is heat transfer ng radiation, of course na gyud kay T1 temperature difference. Ay kalimti kung wag temperature difference, mapa radiation pa man na, mapa convection or mapa conduction, wa gid gihapon o heat transfer. Dapat na temperature difference. That's why si sun is hotter than the earth. So mo nang ang flow sa radiation is from the sun towards the earth. So again, radiation is caused by electromagnetic waves from a hotter body to a colder body. And also radiation class, napo na siya yung mga kuan, mga principles nga ma-apply sa radiation. And the first one is we have here a black body. Okay, black body. Kasi pasunod ng black body, actually not only si sun maka radiate og energy, all bodies class. Okay, all bodies as long as iya temperature kay dili 0 kanang Kelvin. Of course, ang tarang objects nga naa sa atong surroundings above absolute zero magina siya. So therefore tanan nag-emit every second, nag-emit ta og kanang radiant energy. Okay, nag-emit ta og radiant energy. Let's say we have here an object A, and then I'm going to draw another object pod, an object B, then another object C. So kani sila na sud sa room. So si A nag-emit og radiation. A is emitting radiation, and also B nag-emit po na siya. C emit pod siya. Okay, and of course di lang pod sila nag-emit, si A pod mo accept po na siya. So therefore si A mo accept pod og radiation, radiant energy coming from the outside sources, and also the same with C. So that's why energy is conserved here. Okay, na may pagawas sa ilaha, napoy misud sa ilaha. So man siya they interact with each other. And for a black body class, black body na siya nga material if iya ma-absorb 100%, absorb or ma-emit niya 100% ang radiant energy. Of course, sa ato diri walay maka-reach og nearly black body kay more ideal man siya. So almost black body lang. Let's say ang iyahang emissivity, so natay gitawag emissivity in a black body, natay gikuan nga parameter nga emissivity. We denote that one as E. So ang emissivity for objects around mga 0.9 or 0.95 nga na siya. And then magay na ang reason especially sa atong mga kanang sa ato ang kuan sa atong roof. Now black body actually kung imo pinturahan og black ang sak material kusog ka na ma-absorb mo or emit og kuan mo absorb og radiant energy. That's why ang pintura sa atong scene or na mga abang scene gituyo na nga kanang shiny kay or silaw para i-reflect. Okay, let's say mo na itong balay ang color aning sa roof kay dapat sinaw siya nga naman para ang radiant energy gikan sa sun iya i-reflect back. Okay, i-reflect niya back para dili siya mo conduct through the roof then ngadto sa atong rooms kay mas uminit na atong balay. Now kung imo na pintura kag black, so mo nearly black body siya. So what happens is that ang radiant energy di siya mo reflect, fully absorb siya almost 90%. So mo na mga to mainit, that's why nagselect mga pintal nga mo reflect back. Okay, i-reflect back ang radiant energy. So mo na siya. And since we're talking about this emissivity and also for the black body, now this time at it derive ay formula. So ang kuan ang kayang radiation energy actually nag-base ni siya sa Stefan Boltzmann nga law. Okay, si Stefan Boltzmann. Stefan Boltzmann's law. Okay, for Stefan Boltzmann, the the amount of energy that is being emitted by a certain object is equal to, that is let's say that is P na lang, P is equals to the emissivity, that is E, and of course the area. So mas daw ang area o daghan po kag ma-emit, that is the area of the object, then the Stefan Boltzmann constant na say constant nga kani siya marag sigma, and then T raised to the power of 4, so to the 4th kanang kwan power kani siyang kan temperature for Stefan Boltzmann dapat naka-absolute ni siya, meaning it's either Kelvin or Rankine. Take note, kung naka-temperature na siya, I mean kung naka-Celsius na siya o naka-Fahrenheit, wrong na jud kadana na. Okay, so muna siya ang ma-absorb sa object or ma-emit. Now, in order to determine the net rate of heat transfer, okay, we're dealing with heat transfer man, let's say mag-consider lang ta og duha ka object or duha ka entity. Let's say we have here object A and then its surroundings. Okay, its surroundings, and I'm going to label that one as entity B. Okay, of course si A mo radiate siya og heat. Syempre kaning B nga surroundings mahatag pud siya ni A. And of course si B mo follow pud sa the same formula, that is EA sigma T to the 4th. So therefore si A, ang surface ni A has a temperature TA. And of course for B, the surroundings, it also has a temperature of TB. And if si A kay mas hotter sa surroundings niya, therefore na heat transfer nga mahitabo. So the net rate of heat transfer is represented by Q. That is equal to the difference of the amount of energy being emitted by a certain object, that is emissivity area sigma T to the 4th. So that is for A, that is E, area ni A, then theta, then TA to the 4th minus E. Now since namta sa surface phenomena, so therefore automatic A gihapon is dira nya sigma, so same ra ang sigma for all materials, sigma ra gihapon, then T to the 4th with letter B. So therefore simplifying, we have EA sigma, then T to the TA to the 4th minus TB to the 4th. So this is the formula for radiation. And of course unit analysis, so emissivity unitless ni siya, heat less. So therefore Q here is watts. The area here is meters squared, and of course kaning temperature is Kelvin to the fourth. So therefore automatic ang unit sa Stefan Boltzmann nga constant. Okay, Stefan Boltzmann nga constant ha. Para mahimo na siyang watts is, of course, ato na siya i-over. I-over na to meter squared Kelvin to the fourth para makancel niya watts dire. Mana siyang unit analysis. And what is the value of the Stefan Boltzmann constant? Actually, na po sa calculator, but you can memorize that is 5.67 times 10 to the power of negative 8. Okay, times 10 raised to the power of negative 8 watts per meter squared Kelvin to the fourth. Mana siya? Mara gini niya tigaman for radiation. So that is emissivity times the area times the Stefan Boltzmann constant, sigma, then to the fourth power of its temperature. And this equation comes from the Stefan Boltzmann's law. So just a review, again for conduction, gikan siya ni Fourier nga law. Convection, gikan siya ni Newton's law of Cooling, Q is equal to hc a delta T. And the radiation is Stefan Boltzmann's law. P is equal to a actually this is EUT. EA sigma T to the fourth. So muna siyang heat transfer. So by having that, now let's try some kanang problems. Sample problem. So here, problem for conduction. So it states that an owner of the house designed one of its wall 2 meters high and 2.65 meters long with 3 layers comprising of 0.2 meter concrete. So nag-una ni si concrete, ni follow si 0.5 inch nga sheeting. Okay, daghan siya insulation. And then 3.5 inch fiberglass nga batting and 0.5 inch drywall. So sa duha tulo upat ka insulation. The concrete, sheeting, fiberglass batting, and the drywall has a thermal conductivity of 0.8 joule per second, or joule per second meter per degree Celsius. 0.8 pod ang fiberglass, then 0.7 ang kaning sheeting. So 1, 2, 3, 4. And then 0.56 si drywall. And 0.72. Actually, kana siya redundant ni. So, what is siya? Then, if he keeps his room at 5 degrees Celsius, so therefore, as you notice, naka 5 degrees, find the energy transfer rate through the wall at an outside temperature of 20 degrees C. So, kani, outside temperature 20 degrees C. So, meaning, inside his room, pila daw heat transfer padong gawas. Okay? Pila daw. So, to solve for this, so let's start by defining the given data. So, since na siya wall, party ra sa wall ang atong gi-analyze, so therefore we have some dimensions. That is, the length is 2.65 meters. The height is 2 meters. And then of course for every insulation we have some thickness. Okay, thickness. So let's say we can just say x na lang atong pag-represent sa thickness. You can have L, it's up to you. So x na lang. That is for x sub 1. This is for the concrete. That is 0.2 meters. 0.2 meters para ni siya sa concrete. X sub 2, this one is for sheeting. That is 0.5 inch. So ako na convert 0.5. So that is 2.54, 1 inch, 2.54. So the result is 0.0127. So x sub 2 is 0.0127 meters. This is for the sheeting. Ikatul x sub 3. So again, these are the thickness sa atong insulation. For fiberglass, so we have 3.5 inch. 3.5 inch is 0.0889. So 0.0889 meters. This is for fiberglass. Then the last one, x sub for drywall, that is 0.5 inch. So same ra gyapon sa sheeting, that is 0.0127 meters. That is for drywall. What else? Okay, ilahang equivalent nga thermal conductivity. So for concrete, K1, that is 0.8. Actually, joule per second can be written as watts. So watt per meter degree Celsius. For K2, that is for sheeting, that is 0.7 watts per meter degree Celsius. For K3, this is for fiberglass. Okay, for fiberglass, this one is 0.56 watts per meter degree Celsius. And then the last one for K4, this is for drywall, we have 0.72 watts per meter degree Celsius. Of course, we have an inside temperature. Let's just label this one as Ti is 5 degrees Celsius, and the outside To is equals to 20 degrees Celsius, meaning mas init sa gawas kaysa sa sud. So what we're going to find here is the rate of heat transfer. So required is Q. Okay, the rate of heat transfer. So solution. Now this is a conduction for composite materials. So we're going to draw first its equivalent nga kanang heat diagram. So from the inside, that is Ti, then naay usa ka resistance. This is for the concrete, that is for R1, because 1 represents for concrete, followed by the sheeting, that is the resistance for sheeting. Next is the resistance for fiberglass. The last one is the resistance for drywall, R4. Then finally to the outside, that is TO. So here we can say that the total resistance, R total, is equals to R1 plus R2 plus R3 plus R4. And we know that in terms of the given data, that is equal to X all over K times the area. Okay, xk times area. So solution, from the heat diagram we can say that that is Q is equal to since this is current, that is delta T over R. That is delta T all over R total. And we know the delta T, so let's start with Ti. So Ti minus To all over the R total is R1, so that is R1 plus R2 plus R3 plus R4. Then we all know that the formula for the resistance is the thickness all over the thermal conductivity and the area. So that is Ti over To all over. Actually, we can extract the area because all of them, they have the same area. So extract na to, that is 1 over area. What's left is for x1 all over k1 plus x2 all over k2 plus x3 all over k3 plus x4 all over k4. So yeah, then the area, this one is also equal to length times the height. That would be ti minus to 1 over length times height, x1 k1 plus x2 k2 plus x3 k3 plus x4 k4. So, siya. Then substitute the values. So try substitute ang values. So it will be equal to Ti is 5 degrees Celsius. So 5 degrees minus 20 degrees divided by 1 over the length is, this is Celsius na siya, or Celsius, or since this is difference, you can have degree Celsius or Kelvin. So 1 over length is 2.65, so that is 2.65 times 2. This one, the overall dimension is meter squared. Then here, the x sub 1 is 0.2. So we have 0.2 over k1 is 0.8 plus x sub 2 is 0.0127 all over 0.7, then plus 0.0889 all over 0.56 plus we have here 0.72, sorry, like there, this is for x sub 4, x sub 4 is 0.0127 all over 0.72, and of course uniform ni sila, so they have the same kuan, the same rin ilahang ilahang kuan class, so same rin na. So this one would be ang iyahang kuan ani, iyang unit ani is meter per watt per meter Kelvin mo na siya. Then per Kelvin makancel na siya, ang meter square diri makancel sa ma-meter na lang ni, okay, ma-meter, and then sa ubos, so na may meter usapod sa kinabusan makancel pud ni, so what's left is the watt only. Therefore simplifying this using your calculator, that is 5 minus 20 negative 15 all over 1 over 2.65 times 2 multiplied 0.2 over 0.8 plus 0.0127 divided by 0.7 plus 0.0889 divided by 0.56, then plus 0.0127 divided by 0.72. So the answer here is negative 178. Negative 178.84 approximately watts. So why is it that we have a negative answer? Because it means that kuan, ang flow ani is pagawas instead of pasulod, tungod kay milos ang kuan, ang direction gid ani is opposite sa ato ang assumption, di ba? Ato gi-assume diri kay ang heat kay padong sa gawas, or in fact ang in reality pasod gid siya. Why? Because of course kung inyo makita mas higher temperature man, di ba, normally from higher temperature to low temperature. That's why si Fourier nagbutang siya negative sa K, diba, siya in general formula. That's why let's just take the absolute here. That is 178.84 watts. That is to the inside. Okay, so this is our final answer. Let's proceed for convection. So here room is to be maintained at 20 degrees Celsius during the winter season with outside condition of 1 degree Celsius. The convection heat transfer coefficients in the inside and outside are 0.5 watts per meter squared degree Celsius and 0.87 watts meter square degree Celsius. The total surface area of the walls of the room is 100 square meter, and its thickness and thermal conductivity are 0.7 meters and zero point 0.8 joule watts per meter per degree respectively. Find the heat rate transfer from the room towards the outside environment. So again, here ato sa icon ang figure and data or just the figure. So assuming mo ni atong kuan partition sa wall. Okay, partition sa wall. And we have inside condition and we have outside condition. So in the inside condition, it is maintained at 1 degree Celsius. This one is, the outside is at 20 degrees Celsius. Sorry, baliktad. Ang inside kay during winter man. So meaning, padakan din mo sod. During winter, the inside is 20 degrees C. The outside is 1 degree C. So here, nagingan po diri nga, ang surface pod, okay, okay, wala raman di ay. So here, napod tayo kuan heat transfer coefficient. Let's say HCI, that is for the inside, that is 0.5 watts per meter squared degree Celsius. And then HCO is equals to 0.87 watts per meter squared degree Celsius. So, mana siya ang heat transfer coefficient. And of course, we also have K here. Thermal conductivity, that is 0.8 watts per meter degree Celsius. So, mana siya. Of course, nani siya thickness. Nani siya thickness nga 0.7 meters. Mana thickness sa wall. And of course, it has a total area of 100 square meter. So basically, since the inside is much hotter than the outside, so therefore ang rate of heat transfer ani or ang direction sa heat transfer is from the inside towards the outside. And we're going to solve for this Q. Mamay pinita. So here we can have first the heat diagram. So here we have, this is a combination of convection and conduction. Why? Because from the inside, so this is Ti, from the inside, nasa convection nga nahitabo bago mag-conduction. So therefore, we have here the resistance for convection at the inside, Ri. The next, na conduction na pod sa wall, that is R sa wall, resistance sa wall. And lastly, the convection heat transfer at the outside, RO. Usa paning maka-achieve sa TO. So here, we have a total resistance equal to Ri plus Rw plus RO. Okay, so that's why i-take na dito yung mga resistance, yung mga formulas for actually gi-derive raman po to. If you already know the principle, then it will be easier for you. Heat diagram. So solution na ta. Solution. So solution, the Q is just equal to delta T all over the total resistance. And we know that the total resistance, so this one is delta T all over Ri plus Rw plus Ro. So since the same naman ang area throughout aning circuit, aning heat diagram, that is delta T equals to okay, ito na tagtagsan para yung maglibog. So for Ri, the resistance for convection is 1 over HCI times the area, plus for conduction, that is X all over K, then area, plus the convection upon outside, the HCO area. So here, pwede din na ito ma-extract ang area. Delta T over 1 over A, then 1 over HCI plus X over K plus 1 over HCO. So, substitute the values. Okay. Delta T, that is 20 minus 1, so that is 19 degrees Celsius or Kelvin. Then 1 over the area is 100 square meter, so 100 square meter. Then 1 over HC is 0.5. Then plus here, we have X of 0.7 all over this one is 0.8 plus 1 over the heat transfer coefficient in the outside is 0.87, and of course ang unit ani is kanisiya meter squared. Okay, meter squared degree Celsius over watts. Therefore makancel na siya, cancel po ni, what's left is just the watt. So therefore Q is equal to, ito na i-simplify, so we have 19 1 over 100 times 1 over 0.5 plus 0.7 by 0.8 plus 1 over 0.87. So the answer is 472.12. So 472.12 watts. So muna siya ang heat transfer from the inside towards the outside. So ingana na class. Then let's proceed to the radiation. So radiation ta. So here we have a member of a polar bear club dressed only in bathing trunks of negligible size prepares to plunge into the Gulf of Finland from the beach in St. Petersburg, Russia. So the air is calm with a temperature of 5 degrees Celsius. If the swimmer's surface body temperature is 25, compute the net rate of energy loss from his skin due to radiation. So how much energy is lost in 10 minutes? Assume his emissivity is 0.9 and his surface area is 0.5 square meter. So here, radiation is siya. So ato sa indicate ang figure and data. So let's say man siya ang kuan polar bear club. So tao, and then iyang surrounding air. So natay T sa surrounding TS is equals to 5 degrees Celsius. And then siya, so ang T sa human, TH na lang, is equals to 25 degrees Celsius. So mas init siya, so meaning siya graduate of heat. Okay, and then ang iyang area, so area sa human, surface area niya 1.5 meter squared. Again, surface area tungod kay the heat transfer is a surface phenomena. And then next is we have an emissivity. Emissivity E is equals to 0.9. Okay, 0.9. And then what else? So kuan ang required dapat time is for 10 minutes daw. Okay, so required, here we're going to solve for the net rate, that is Q, and then The second one is the energy. So the energy, that is P, wherein P is equals to Q times the time. Kaya ang Q is P over T man na siya. So solution, that is for radiation, Q is equals to, again, emissivity, the area, Stefan Boltzmann constant, and then the difference, that would be TH to the fourth minus the surroundings to the fourth. Dapat naka Kelvin na siya. Don't forget. Emissivity is 0.9. So we have 0.9. The area is 1.5 meters squared. The Stefan Boltzmann constant is 5.67 times 10 to the power negative 8. Actually, dagam siya point. So, ano lang, watts per meter squared, that Kelvin to the fourth. Then multiplied by TH. So, ato na siya i-convert into Kelvin. That is 25 plus 273 raised to the power of 4 minus 5 plus 273 raised to the power of 4. That is in Kelvin to the fourth. Therefore, makancel ni. Cancel. Ang meter squared makancel. What's left is watts. So, Q is equals to, simplifying, 0.9 times 1.5 multiplied by the Stefan Boltzmann constant, 5.67 times 10 to the power of negative 8. Then multiplied by 7 plus 273 to the fourth minus 5 plus 273 to the fourth. The answer is 162.83. That is 162.83 watts. Muna siya ang iyahang na ang iyahang na lost. Itong kay radiate siya kasi may mas init. So, radiate siya mas siyang na lost. And pilay energy nga na lost niya in 10 minutes. So, that would be P. Okay, this is our first answer for the heat rate. Then the second one is the energy. So, that is P is equals to Q over Q times time. Sorry. P is Q times time, so that is Q is 162.83. That is joule per second, ha? Ang equivalent sa watts. Then that is for 10 minutes. So you have 10 minutes, and we know that 1 minute 60 seconds. So therefore cancelled out. This will be cancelled out. What's left is joules. That is 162.83 multiplied by 10 multiplied by 60. So the answer is 97,698 joules, or 97.70 kilojoules. Mana siya ang total energy ngayang na lost after after 10 minutes. Paspas kayo. Okay? So, let's proceed to the kinetic theory of gases. Okay, class, so let's continue our discussion. So we are now on the principles of kinetic theory of gases. So these are the important key points for the kinetic theory of gases. So the gases consist of particles at constant motion. So meaning it doesn't have any acceleration, so uniform motion. Then mostly gi-assume siya nga empty spaces. So empty spaces, we only have kanang gas molecules nga present, and then it exerts pressure when colliding the walls of the container. Because let's say if we have a sample container, container, and then we have here some representation of our gas molecules. So in this theory, you assume nga inside the container, mostly empty spaces. So wala na lang present aside from the gas molecules. And then these gas molecules, of course, they are in motion, so constant motion, no acceleration. And then it collides to the wall and it exerts pressure, so meaning na siya force exert, then mo balik na pod mo bombard siya. So that's why we can feel this one. So that's why we have a total pressure. So mao nang sa balloon. Okay, if we have a balloon, natay balloon, so if nag-collide ra ang mga molecules, so that's why natay mo dako ang balloon kay naanay pressure gi-exert, sige na sila bombard with each other at a constant motion. And then particles don't interact. So when we say particles don't interact, meaning if they collide, so kan siya kanang perfectly elastic na collision. So this line nga magsikit, this ingon nga kanang na energy nga malots, so wala interaction, simply they just collide with each other, then mo recoil sila, mo bounce back. So nothing more, nothing less. And then molecular speed is proportional to temperature. So meaning the amount of speed na nila, so kana siya nag-collide na sila with each other and also in the walls. Now if the more they are kanang the more ila have velocity, so the more pod ang increase sa temperature. So kanang the more active they are, so the higher pod ang temperature nila ma-generate. Mo na makita na nato sa pagbukal og tubig. So when we boil water, so lang ang excitation sa excitation sa molecules kusog kaayo, so mo nang sislag bombard with each other, so therefore increase ang temperature. So basically these are the keynotes for the kinetic theory of gases. So let's proceed with specific heat. So specific heat, this is the capacity of a certain material to store heat energy. Okay, capacity of a material to store heat energy. Capacity of material to store heat energy. To store heat energy. And diba, we're talking about heat. Now, wapat na ako gi-introduce sa inyo ha kung unsa gid ay formula for heat. So the general formula for heat, this is that as the heat equation is simply Q is equals to M, the mass, of course, for a certain material, like siya mass, then we have here Cp, and then the change in temperature. So again, diba, for every kanang heat energy nga problem, na ganay change in temperature. Kay if wala change in temperature, meaning wala heat nga i-transmit ang body. So M Cp delta T, wherein this one is the amount of heat. This would be in joules or maybe in watts in some cases, wherein if our mass here in per second, if mass flow rate, and then our Q will be in watts. So our mass here is in kilogram, then Cp here is joules per kilogram degree Kelvin, and of course this one is in Kelvin or Celsius, kay anyway same naman siya kay difference naman sa temperature. So this is the general formula for the heat energy of a certain material. So it is a function of its mass, the specific heat. So this is a property this is now a property of a material. Property of a material. Now, makabantay mo maunang kung magtimpla tag kuan kanang kape ato isod sa mug, so dugay siya mabugnaw tungod kay ang mug kay di man metal. If metal pa na siya, kadyo na siya mabugnaw tungod kay kusog ang heat loss. So igamit kay kanang mga ceramics, kay ang ceramics kay taas man siya specific heat, meaning taas siya ma-store nga heat niya, i-store niya for a certain period of time, much longer if magamit ta og metal. So the higher the specific heat, meaning the high capacity nga mo-store siya og heat energy at a longer time. So mao na ang sikat nga working substance is ang water. Okay, and then ang specific heat napon siya duha ka type. two types of specific heat. We have the first one, we have specific heat at constant pressure, meaning if the process is at constant pressure, so atong gamitin nga specific heat of a material is we have Q is equals to m Cp delta T. And we also have another type, the other type, which is at constant volume. So these are material that will not vary if na ay process nila, either dokdokon sila, ada nung heat niya, di yun mo change kayo. Okay, at a certain temperature range. So that type of CpVQ is equals to m Cv delta T. So this is the specific heat at constant volume. So this is more applicable for solid objects. Why? Because if you're going to add energy on a solid, diba dugay ka na mo change yung volume. So constant volume nila. Whereas kaning constant pressure, this can be applied to fluids. Okay, fluids na siya kay especially for water, mag-change man ang tubig. Okay, fluids. And even gases. Okay, change man yung volume. But of course, ang fluids na po na siya corresponding CV. Okay, every material na gina siya yung corresponding specific heat at constant pressure and specific heat at constant volume. Now, for the specific heat, natay daw ka-importante ng mga working substance. And let's start with the air. Okay, let's start with the air. So the air has two specific heats. We have specific heat at constant pressure, that is Cp. Cp of air is 1.0062 kilojoules per kilogram degree Celsius or degree Kelvin. And then it's Cb. So muna siya yung mga specific heats. Cv niya is 0.716 kilojoules per kilogram degree Celsius, or in English this is equal to 0.24 BTU per pound degree Rankine, and this one is 0.171 BTU per pound degree Rankine. Mano siya ang specific heats for air, mano siya standard. This is at standard temperature and pressure. And the next important nga working substance, especially gamitan sa mga problems and also in our field, is the water. Okay, the water, H2O. So ang water na siya ay Cp or C na lang. Okay, for water actually di ka siya mag-vary if at very low temperature Cp lang. Okay, at constant pressure lang Cp sa water is equals to, or some say C na lang, C sa water is 4.187 kilojoules per kilogram degree Celsius or degree Kelvin. So wala siya take note mga cons. These are important constants nga magamit nato, especially if we're solving kanang thermodynamics nga problems. So muna siya in specific heat, we have two at constant pressure and at constant volume. So let's have here an example problem. Let's say the temperature of a silver bar rises by 10 degrees Celsius when it absorbs 1.23 kilojoules of energy by heat. The mass of the bar is 425 grams. Determine the specific heat of silver from this data. So again, we're going to write first the figure and data. So let's say this is a silver bar, and then it has a temperature rises man, meaning that is the change in temperature, that is delta T, is equals to 10 degrees Celsius. When it absorbs, so when we say absorbs, meaning the heat is being inputted to the silver bar. So gisod, gipasok. So ang direction sa heat, again, heat is a vector quantity. So na siya direction, either pasod or pagawas. I mean, not a vector quantity pala, ang direction lang kung pasod ba siya pagawas. So here we have Q input, sa silver, that is 1.23 kilojoules. Then the mass of the bar, so the mass of the silver bar M is equals to 525 grams, or in terms of kilogram, that is 0.525 kilogram. So here determine the specific heat. Okay, specific heat. So we are going to require to solve for the specific heat C of the silver. So silver is Ag. So specific heat sa silver. So solution. So by the general formula of the heat energy, so that is heat is Q is equals to mass of the material C sa material. Here we are dealing with silver bar, then change in temperature. Since we're obtaining with CAG, so divide both sides by M delta T. So this will be cancelled out. Na siya. So we now have nanalantay specific heat sa silver is equals to Q over M delta T. So Q here is 1.23. Actually, ang ato answer lang ani is in kuana lang ni siya in kilojoules per kilogram degree Celsius. So 123 kilojoules divided by 0.525 kilogram multiplied by change in temperature 10 degrees Celsius. So our answer is, so simplify, 1.23 divided by 0.525 times 10. So the answer is 0.234. So 0.234 kilojoules per kilogram degree Celsius. This would be the specific heat of our silver bar given this data. Okay, let's proceed to the next. So we have here a 5-gram lead nga bullet is traveling at 3 times 10 to the power of 2 meter per second, or 300 meter per second, is stopped by a large tree. If half the kinetic energy of the bullet is transformed into internal energy and remains with the bullet while the other half is transmitted to the tree, what is the increase in temperature of the bullet? So we have here figure and data. So the bullet travels at a speed of 300 meter per second. Okay, and then the mass is 5 grams, or in kilograms is 0.005 kilogram. Okay, 0.005. So next, idasmag na siya. So saka kahoy, let's say this is a tree. So dasmag siya sa kahoy, may impact, and then sa pag-impact niya, of course, it generates heat, ba? Generates heat. And then here at this position, at this point, ang iya kinetic energy, since it has kinetic energy here, ang half ani kay mingadto sa bullet, so that is 1/2 of this kinetic energy mingadto sa bullet, and then the other half is mingadto sa kahoy. So 1/2 Ke mingadto sa kahoy, na transmit sa kahoy. So therefore, unsa increase sa temperature sa bullet? So meaning natay input in the second position sa during collision natay input nga heat energy ngadto sa bullet mo, na init siya. That's why it is termed here internal energy. So meaning init ang bullet due to the collision. So half of that energy mo ay ni resulta nga miinit siya, because the other half is ngadto pod kay init ang butong kahoy nga ayan nadasmagan. Pero kadto lang nga spot nga naigo. So half la sila. And ang required we are going to solve for the increase in temperature, that is delta T. So let's solve. Solution. So that is a general equation for Q. So we have Q is equals to mass sa bullet, then C sa bullet, and then delta T. C sa bullet, then delta T. So ang Q, the heat energy ng input sa bullet is just 1/2 of its kinetic energy. So that is 1/2 mass sa bullet and square sa velocity sa bullet is equal to mc cb, meaning specific heat sa bullet, this is cb, and then delta t. So as you can see, makancel ang mass, so and then divide both sides by cb, so we have change in temperature is equal to v squared all over 2cb. And then we have here kanang koan, given nga velocity. So so naman diri ang given nga kanang velocity. So ang given velocity kay man 300, so 300 meter per second. So we have here 300 squared all over 2 cb. So that would be 300 squared divide by 2. So we have 45,000. That is 45,000 over cb. So this is our final answer because cb is not given. Mao ni siya ang equation for its temperature rise. If ever natay cb, then we can just substitute this one directly. So again, 1/2 plus sa kinetic energy ang nangadto sa ngadto sa bullet. Okay, so we have the last example for specific heat. So we have here a cylindrical water tank, 0.5 meter in diameter and 2 meters high, has a temperature of 24 degrees and at full capacity, meaning puno siya. Find the equilibrium temperature if a 20 kilogram aluminum ball initially at 50 degrees Celsius is dropped inside the tank, assuming that the tank doesn't overflow throughout the process. Specific heat of aluminum equals 0.29 joules per gram per degree Celsius. So here we have figure and data. So we have here a tank. Okay, puno siya sa tubig. So iya height is 2 meters and then iya diameter is 0.5. Okay, 0.5, and then initially ang temperature niya is 24 degrees Celsius, and then ang equilibrium ang kuan ay gi-drop. So we have here another object being dropped inside. So we have here an aluminum ball. So the aluminum ball has a mass of 20 kilogram and a temperature, so temperature of aluminum TAL is equals to 50 degrees Celsius, meaning mas init ni siya. So init ni niya gi-drop sa sulod. So meaning na possibility nga mo increase ang temperature sa tubig kunya mo gamay ang temperature sa aluminum, kay meaning yung give off man kay mas dako man siya, di ba? Again, ang flow sa energy is heat energy is from high temperature to lower. So meaning hing give off si aluminum, hing gain si water. So napoy given nga specific heat. So specific heat sa aluminum is equals to 0.29 joules per gram degree Celsius. So what are to find here is the equilibrium temperature. Nilang duha kay maabot mo na sila sa equilibrium temperature. So that is TE, equilibrium temperature. So solution. in solving this, imo ra equate nga ang energy nga na loss, so meaning isolated man nga system, ang energy nga na loss, that is Q nga na loss ni aluminum is just equal to Q nga na gain ni water. While labot na ang kanang tank kay given ang specification sa tank. So man siya Q loss of the aluminum, ang nahatag ni aluminum equal pod sa nadawat ni water. So what is Q for aluminum? That is mass sa aluminum, Cp sa aluminum, then delta T. Okay? And here pod mass sa water, Cp sa water, delta T. Actually, they have the same final temperature, di ba? Kay ang mass sa aluminum, that is the delta T of aluminum is the equilibrium temperature minus yung initial, that is 50. That is equal to mass of water, Cp sa water, delta T is the equilibrium temperature minus the initial sa water, that is 24. Okay, we have mass aluminum, we have also given the specific heat of aluminum. How about for water? So we all know, kaganiha, that the Cp of water is equals to 4.187 kilojoules per kilogram degree Celsius. And then also, how about for mass of water? We don't know sa mass of water, but take note, kay ba man to sa volume, and then automatic kay ba to sa density sa water, di ba? Mass of water is just density sa water times the volume sa water. Now the volume of the water is equal to the volume of this cylinder kay at full capacity man. So density sa water is 1000 kilogram per cubic meter multiplied by the volume, that is pi ang pi r squared or pi d squared, that is 0.5 squared all over 4. The height is 2 meter, that is 2 meter. So the answer would be in kilogram. So that is 1000 multiplied by pi, then 0.5 squared all over 4 times 2. So the answer is 125 pi. 125 pi kilogram. Now we're going to substitute this in our equation. So solving for common siya, solving for TE. So we now have mass aluminum CAI TE minus 50, and then MAL CAI is equals to mass sa water C sa water TE minus 24 mass sa water C sa water. Sumar siya. And then class, since nakaseparate na magud ni mga temperatures, don't forget to convert it into kanang Kelvin. Okay? Kelvin gini siya kay kuan magud wa na magud nag-usa gud ang mga temperatures. So mas better kaning 50 i-add pa nimo og 273 o kaning 24 kaning duha para ma-save ka. So unya na lang. And the same thing with this one. Okay? So combining TE, so transposing this on the other side, so we have here TE multiplied by mass sa aluminum, Cp sa aluminum minus mass sa water, Cp sa water is equals to this one also transpose, so we have here 50. Okay, we have there 15 siya. So this one is 50. Then naturally add plus 273 mass sa aluminum, Cp sa aluminum minus 24 plus 273 mass sa water, Cp sa water, and divide both sides by mass aluminum, Cp sa aluminum minus mass sa water, C sa water. The same thing here, mass aluminum, C sa aluminum minus mass sa water, C sa water. So therefore cancel na siya. So what's left is TE. So TE here, the equilibrium temperature is equals to this is 50 plus 273. Mass aluminum is 20 kilogram. 20 kilogram. C sa aluminum dapat ato siya i-convert. para consistent ta. So convert this into kanang kilojoules per kilogram. So we just multiply, divide 1000 joules 1 kilojoules, and then 1000 grams 1 kilogram. Anyways, makancel ra. So this is just equal to 0.29 kilojoules per kilogram degree Celsius. So i-multiply ra nato. So we have here 0.29, then minus 24 plus 273. Mass sa water is 125 pi. CP sa water is 4.187. The same thing, mass aluminum 20 times 0.29 minus 125 pi multiplied by 4.187. So temperature, equilibrium temperature nila, so 50 plus 273, 50 plus 273 multiplied by 20 times 0.29 minus 24 plus 273, then 125 pi times 4.187, then divided by 20 times 0.29 minus 125 pi times 4.187. So the answer is 296.91. 296.91 degree Kelvin is here. And if you want this into degree Celsius, that is TE is equals to 296.91 minus 273. Okay, so the answer would be, so minus 273, the answer would be 23.91. So 23.91 degrees Celsius. So gamay ra kayo ang pagkuan, ang hing drop down yun ang kuan, hing drop down og pamaayo ang aluminum since daghan kay ang tubig. Okay, lima ka daw kay ang mass sa tubig daghan kayo. So ang tubig pod nga kuan at 24, so at 24 degrees Celsius man siya, so may gamay pod. Okay, so I think mao na siya. So this would be our kuan kanang final answer. So ito box mara siya 23.91 or murag yun siya kuan almost 24. Murag what ray effect has no effect since gamay ra kay ang aluminum kay may butang.